Hello Year 7s. So in this lesson we're going to be talking about tables and rules. Now remember, as always, you shouldn't just be watching this video, you should be taking down some notes as well. Let's begin by talking about our learning objectives. So our first learning objective is to understand that a rule connects two varying quantities. Next, to be able to complete an input-output table given a rule, and finally to be able to find a rule in the form output equals such and such for an input-output table. So there's a lot of information right there, and some of it might not make any sense at the moment. So let's begin this lesson with a starting activity and hopefully make sense of what we've just read. So here's our scenario. An archaeologist found two different femurs from two different people, but did not find the whole skeleton. So here are the femurs that she found. She found this femur, which belongs to one person, and she found this femur, which belongs to another person. Now, to find the height of these people, the archaeologist uses a rule which connects the length of the femur to the total height of a person. So let's just take a step back and really consider what we're being told here. So this archaeologist found two femurs, and then she measures them. This one is 30 centimeters. This one is 40 centimeters. Now she's hoping to use this information, the length of the femurs, to figure out what the total height of the person is. And that's where this rule comes into the play. So this rule connects two varying quantities. And if you remember back to our learning objectives, we have to understand that a rule connects two varying quantities. So up here, we have two varying quantities, our height of the person and the femur length. And this is a rule that connects them. So to find the height of someone, what we do is 3 times the length of the femur, then plus 50 centimeters. Now, we also have this input-output table, which again, if we go back to our learning objectives, was something else we needed to know, our input-output table. And this really just displays what we're trying to do. So our input here is our femur length. So kind of think of our input as what we know. We know our femur lengths. It's what we dug up from the ground and then measured. We know that one is 30 centimeters and one is 40 centimeters. Our output is what we're trying to find. Our output is what we're trying to find, which is the height of the person. Now, these two things, our input and output, are connected through this rule. Now, just so we all are on the same page, let me just bring this over. Ready? There we go. Let me bring that a bit over there. So this is telling me that my height and my output, they're the same thing. And my femur length and my input, they're the same thing. We're just using different words. Hopefully you kind of get the connection there. Nothing too bad. So the height, that's my output, is what we're trying to find. And my input is that femur length, is what we know. So we need to fill out this table. We need to find the height of the person if their femur length is 30 centimeters. Now, to do this, we simply utilize our rule. So I'm going to come over here and I'm going to take this 30 centimeters and I'm going to put it into my input. So I'm going to take this 30 centimeters, put it into my input, and it will spit out the output. So let's try that now. So my output, whoops, if I can spell, my output is going to be 3 times my input, which is 30. Then I'm going to plus 50. And I just need to do something. That bracket is just so ugly. I need to fix it. That's better. 3 times 30 is 90. Then I'm going to plus 50. 90 plus 50 is 140. And we're talking about centimeters here. So we come over here now. My output for when my input is 30 centimeters is going to be 140 centimeters. Let's now do the other one. So what happens when my input now is 40? Well, yet again, we take it and we put it in to my input. So let me get rid of that line. So this time I'm going to go, my output equals 3 times, this time 40, so I'm substituting that in. Then I'm going to plus 50. 3 times 40, what is that? That's 120. And then I'm going to plus 50. So that's going to be 170. And again, we're talking about centimeters, so that's going to be centimeters. So I'm going to have 170 centimeters as my output value. So in this starting activity alone, we've talked really about a lot of things already. We've talked about two varying quantities being linked together with a rule. We've used an input-output table. So hopefully this really situates you as to what's going on in this topic. Let's now go through some key ideas. So a rule shows the relationship between two varying quantities. A table of values can be created for any given rule. To complete a table of values, we start with the first input number and use the rule to calculate the corresponding output number. We do this for each of the input numbers in the table. Replacing the input with a number is known as substitution. So there's a lot of words there, so let's just break that down. Let's see if we can fill out this input-output table. And the way that we do that is by using substitution. So we're replacing the input with a number. This is known as substitution. So to do this, to find what my output is when my input is 1, I'm going to go, well, that is going to be 1 plus 2, which is going to be 3. So I'm going to put a 3 in here. Next, what is my output when my input is 2? Well, that's going to be 2 plus 2, which is 4. So I'm going to put a 4 in here. And this is just going to continue 3 plus 2. So 3, 3. This is going to be 5. And then finally, 4 plus 2 is going to be 6. I've ran out of room. Actually, I can fit it in. It's going to be 4 plus 2 equals 6. And just like that, I'm able to fill in my input-output table by using substitution. So let's go through some more examples here. So here it says complete each table for the given rule. So if my rule is output equals input minus 2, so this is my rule, output equals input minus 2, and we need to replace each input value in turn into the rule. So how are we going to approach this? So let's see if we can figure out what my output is going to be when my input is 3. So up here, we just have an example here. So when input is 3, so this is just some space so you can put some working out so you can understand what's going on. So to do this, my output is going to be my input. So my input is 3. Then I'm going to subtract 2, and I'm subtracting 2 because that's there. 3 minus 2 is 1. So that means I put a 1 here. Well, what if I have an input value of 5? What's my output going to be? Well, again, I'm going to just substitute that in. My output is going to equal 5 minus 2. 5 minus 2 is 3. So I put a 3 in there. Hopefully you're able to do the rest of this. So 7 minus 2 is going to be 5, 12 minus 2 is going to be 10, 20 minus 2 is going to be 18. And just like that, we've filled out our table. Let's now come over here, and this would be a good place to pause the video and see if you can do this for yourself. So we have our rule, which tells us that my output equals 3 times the input plus 1. Well, let's give this a go. So we're going to replace each input value in turn into the rule. So here we have our input of 0. So let me actually do some editing in the moment here. I'm going to change this to a 0. Let's do a 0, and let's make this 2. Okay, now that I've done that, let's come back over here. And let's see if we can figure out what it's going to be when my input is 0. So here's just some space so you can do some example working out. So if you ever want to refer back, you can look to see what you did. So my output is going to be equal to 3 times 0. So notice that I replaced my input with 0, and then I'm going to plus 1. Well, what's 3 times 0? It's 0. 0 plus 1 is, drum roll, 1. So a 1's going to live here. Next, when input is 2, so this time what I'm trying to do is find out what my output is going to be when my input is 2. And this is just where we're going to put some example working out. So output is going to be equal to, it's going to be 3 times, my input this time is 2, then I'm going to plus 1. What's that going to be? 3 times 2 is 6 plus 1 is 7. It's going to be 7 there. What am I going to do here? Well, this is going to be 3 times 4, which is 12, plus 1 is 13. For when it's 6, it's going to be 3 times 6 is 18, plus 1 is 17. And for 12, it's going to be 3 times 12 is 36, plus 1 is 37. So hopefully all of that made perfect sense. Let's now move on. So next key ideas. Often a rule can be determined from a table of values. On close inspection of the values, a relationship may be observed. Each of the 4 operations should be considered when looking for a connection. So now we're trying to find a rule for each of these tables of values. So in our previous question, we had been given the rule. We were given the rule and we needed to fill out the table of values. This time, we've been given a filled out table of values and we need to find the rule. So it's a bit like working backwards. So we're trying to find what the rule is going to be. And we're going to do this by closely inspecting our table of values. So let's come over here and see if we can find anything that connects my input and my output values. So here I have 3 and 12 and 4 and 13 and 5 and 14. And what I notice, I'm just dying over here, if I go 16 minus 7, so I'm just minusing my output and my input, 16 and 7, what do I get? I get 9. What if I do it the same over here? So I go 15 minus 6. That also equals 9. What if I go 14 minus 5? 14 minus 5. That equals 9. So what's going on here? Well, it's quite clear that I'm plussing 9. I'm plussing 9 every time. So I'm taking my input and I'm plussing 9 to it. And by plussing 9 to my input, I arrive at my output value. So I'm plussing 9. So let me come over here. So my rule is going to be my output. Whoops, my pen wants to work with me. It's going to be my output equals my input plus 9. And that's my answer right there. Let's now move on to our next one. So rule. This one I think is a bit easier. Because when we look at our outputs, we have 7, 14, 21, 28, 35, and that should be very familiar to us all. That's just our 7 times table. So obviously what's going on is I'm timesing each of my inputs by 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. So if we come over here, what my rule is going to be is my output, whoops, that's a bit too thin. Let's get the thicker one. It's going to be output equals input times 7. Now, obviously, it doesn't matter if you write 7 times input. You could write it like this as well. You could write output equals 7 times input. It doesn't matter. Either of these would be correct because of our commutative law about multiplication. Doesn't matter which order you do it in. Let's now continue. This would be now a good time to pause the video and see if you can solve these for yourselves. Okay, so hopefully you paused the video and you gave these a crack. Let's now see if we can do it ourselves. So we need to find the rule for each of these tables of values. Okay, what's linking these together? So here's my input and here's my output, and immediately it seems like it's minusing 5. Then I go to my next one, I'm like, yep, that's minusing 5 as well. Immediately I see what the pattern is. That's minusing 5. That's minusing 5. And that's minusing 5. So what my rule is going to be is my output. Oh, I keep making that mistake. I keep picking the thinner one. It's going to be output equals my input minus 5. Make sure you get your orders right here. You can't go 5 minus the input. It's my input minus 5. Let's move on to our next one. So here we have 2 and 12 and 3 and 18 and 4 and 24 and 5 and 30. What exactly is going on here? Well, am I plussing something to it each time? It looks like something else might be happening. So let's have a look. Let me grab my pen. How is 2 and 12 connected to each other? Something you can do here actually, if you are running into a bit of trouble, try it. First you should see if there's like a common difference. So this is where our patterns come into play again. Is there a common difference? If I go 18 minus 3, that's 15. If I go 12 minus 2, that's 10. Well, they're different, so that's not going to work. What if I went 36 divided by 6? 36 divided by 6. That's going to be 6. What if I go 30 divided by 5? 30 divided by 5, that's going to be 6. So the fact that we got the same ones right there tells me that we're timesing it by 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. 6 times 6 is 36. That's my favorite multiplication, 6 times 6. I don't know why, because it rhymes. So my output is going to be 6 times my input. So I'm taking my input, I'm multiplying it by 6, I'm multiplying it by 6, and I'm getting my output. So it's multiplying by 6. 6 multiplied my input. Let's keep on going. These are our last two, and then we're going to stop. So make sure you give these a go before you're watching me. So here we have 2 and 5, 3 and 7, 4 and 9, 5 and 11. What's going on here? So immediately you might think, well, 2 and 5, I'm plussing 3. But then 3 and 7, I'm not plussing 3. 5 and 9, I'm not plussing 3. Okay, so what else could I see here? Well, what if I double it? If I double it, it's going to be 2 times 2 is 4, and then I'm 1 short. What if I double this one? 3 times 2 is 6, and I'm 1 short. What about this one? 4 times 2 is 8, and I'm 1 short. So hopefully you can see what's going on here. We're probably not going to give you anything this tricky, but it's good that you recognize what's going on. So what I'm doing here is I'm taking my output, and then I'm going 2 times my input, and then I'm plussing 1. And you can see that if we put in an example. So if we come and look at 5 here. So if I go 2 times 5 and then plus 1, well, 2 times 5, that's 10. Then if I plus 1, that's going to be 11. And that's what we get there. So that's what's happening in that question. So it might seem like a little tricky, and we're probably not going to assess you on anything that hard, but it's important that you see this because you're going to be looking at things like this in your textbook questions. So it's important that we address it here, what's going on. Okay, let's continue on. Let's now look at this one. We have 2 and 17 and 3 and 27 and 4 and 37. So again, this might be a little bit more of a challenging question. And what I would expect you to do for this is to see a little pattern that's going on here. I have 17 and I have 27 and I have 37, I have 47, I have 57. Well, obviously each one is ending in 7, but then something else is happening, and I'm just going to come out and tell you. So hopefully you're able to figure this out. So it's going to be my output equals 10 times my input, and then subtract 3. So let me just bring this up. Whoops. If I can bring it up, can I bring this up? Oh, no, my pen just does not want to work for me. Sometimes technology just decides, no, I'm not going to work for you. Okay. So let's see if this works for one. Let's put in 4. So if I put 4 into this rule here, I'm going to get 10 times 4 minus 3. Well, what's 10 times 4? 10 times 4 is 40. Then I'm going to subtract 3 from that. What is 40 minus 3? It's 37. And that's exactly what we see there. So too, if we did it over here, 5 times 10 is 50, subtract 3 is 47. 6 times 10 is 60, subtract 3 is 57. So that's what we're looking at right there. So hopefully that makes sense in how to get these. And let me just make a note that these two right here, they're more on the more challenging end of things. So don't be too upset if you didn't get them. Just give yourself a bit more time of practice and you'll get there in the end. Okay. Let's now review what we've learned in this lesson. Let's get out our green pen. This is the best part of the job. Let's give some ticks. So to understand that a rule connects two varying quantities, I reckon we can give that a big tick. To be able to complete an input-output table given a rule, let's give that a big tick as well. And finally, to be able to find a rule in the form output equals such and such for an input-output table, we did find rules. So hopefully you feel good about this topic. If you've got any questions, make sure to ask. I hope that you enjoy doing these questions.